Unit 7, Lesson 15, Adding and Subtracting with Scientific Notation. So in this lesson, we are going to learn how to add and subtract scientific notation to answer questions about animals and solar systems. Mentally decide how many non-zero digits are in each number. So non-zero. Well, these all have zeros. And then we have 3 times 2, which is 6, so 1 non-zero. Here, these are all going to be zeros. 3 divided by 2 is 1.5, so 2 non-zeros. This is an adding. So we have 3 followed by 9 zeros and 2 followed by 7 zeros. So 2 non-zeros. And then we have a subtracting. We have 3 followed by 9 zeros. Minus 2 followed by 7 zeros, sorry. So 2 non-zeros. Activity 15.2, Measuring the Planets. Diego, Chiron, and Claire were wondering, if Neptune and Saturn were side by side, would they be wider than Jupiter? They tried to add the diameters, so 4 and 7/10 times 10 to the positive 4 kilometers, or 1 and 2/10 times 10 to the power of 5. Here are the ways they approach the problem. Do you agree with them? Diego says we add the distances. You'll get 4.7 plus 1.2 equals 5.9, and the exponent will be 9. So the two planets are 5.9 times 10 to the power of 9. Chiron says wrote them in expanded form or standard form and then added them. And Claire says, I think you can't add them unless they have the same power of 10. So she made them so they had the same power of 10 and then added. So let's see. So if we're looking at Diego, you add the distances. So we have this. My concern or wonder is, how did he get 9? Because we have 4.7 times 10.4 plus 1.2 times 10 to the power of 5. When we multiply, so if we're multiplying these two, we can then add them, but we're not multiplying, so we can't add our powers. So we disagree. We can't add the exponents. Okay, then we had Chiron. Wrote them both out in standard form. So we have 4.7 times 10 to the power of 4, which is 47,000. 1, 2, 3, 4. I would agree with that. And then 1.2 times 10 to the power of 5 is 120,000. 1, 2, 3, 4, 5. I would agree with that. And then add them. So we have 167,000 kilometers. If we want this in scientific notation, how many values of 10, place values? So 1 power, 2 power, 3 power, 4 power, 5 power. So we get 1.67 times 10. What did we say, 5? 1, 2, 3, 4, 5 to the power of 5. And Claire says you can't add them unless they have the same power, which is a true statement. Originally, this is 1.2 times 10 to the power of 5. To get it so it has the same power, if we need our power less, we're going to move it one less time. So originally it was moved 5 times to the left. 1 less means we only moved it 4 times, which then gave us a power of 4, which is what she has here. And when we add our powers stay, our power of 10, and we get 16.7 because 12 plus 4.7. So this I also agree with. So agree with both. But these are different answers. But they're the same when you write them out in expanded form. Because if we're going to move our decimal out 4 times, so 1, 2, 3, 4 times, we get the same answer. If I were to rewrite this one, moving my decimal one less time, so move it backwards one, I now have 16.7 times 10 to the power of 4. So they are equal. You can add it any other way, or either way. You can write it in expanded form and then add them, or you can make sure they have the same power and then add them. Jupiter has a diameter of 1.43 times 10 to the power of 5. Which is wider? Neptune and Saturn put side by side, or Jupiter? Well, I want a power of 5, so I'm going to use this one that we did up here. Jupiter and Saturn is... So which is wider? Our powers we can cover up for now, which would be wider, 1 in 43 hundredths or 1 in 67 hundredths. So Neptune and not Jupiter, make that an S, Saturn are wider. And we could even tell you how much wider by, it's going to be a decimal, and we're going to subtract that. 67 minus 43. 24 hundredths of a kilometer. So not much wider. That could be a ton wider, though, in planet size. A celestial dance. When you add the distance of Mercury, Venus, Earth, and Mars from the sun, you would reach as far as Jupiter. So if we add how far they all are from the sun, would we reach here? Let's add them all up. So we need their distance. And I want them all to be in powers of 8. This one's not. This is a power of 7. So I'm going to move my decimal one more time. So I have a power of 8. So I now have 579 thousandths times 10 to the power of 8. And I'm going to add them all up, not Jupiter, because that's how far it is, and see if we get the distance. What are your thoughts? Is this going to equal this distance or not? So 579 plus. That only gave me 5. So we would not reach as far as Jupiter. The reason why is because if we were to, let me just this is the sun. And then we got Mercury, Venus, Earth, Mars, Jupiter. The distance is this right here. That's how far it is. Jupiter is all of that and the width or the diameter of each of the planets. The distance from the sun is only measuring to here, from here to here. So when we add up how far each of them are, We are missing the diameter width of each planet. So, no, you wouldn't reach Jupiter. Add all the diameters of all the planets except the sun. Which is wider? All of these objects side by side or the sun? Okay, so the sun is this right here. We need to add all of these up, but we need them either in expanded form or we need to get them all with the same exponents. So let's see. All of them are pretty close to 4, so let's rewrite them all so they have exponents of 4. So this one only moved 3 digits, so we need to move one more. So now I'm at 0.4878. And that's a power of 10 now. Power 4. We need to move this one more. So I have 0.6785. That's a power of 4. And this one I need to move one less. So that's power 4. So now let's add all of these up. So we have 179,363 times 10 to the power of 4. We have another difference that we need to fix though. This one is raised to a power of 6. This one so far has only been moved 4 times, so I need to move it 2 more times, so we go 6 digits, 6 values. 1, 2. So 179,363 times 10 to the power of 6. So the sun is still quite a bit wider than all of these. Let's double check to make sure we have it correct. So I'm going to put all of these in standard form and add them. So if I move the decimal 3 times, I get 4878. 1, 2, 3, 4. 0, 0, 1, 2, 1. 0, 0, 8, 2, 1. Move it 3 times. 6, 7, 8, 5. And move it 5 times. 1, 2, 3, 4, 5. 0, 0, 8, 2, 4, 1. So 8, 9, 10, 11, 12, 13, 16, 8, 8, 16 plus 8 more is 24, 25. Oh man, my numbers did not line up. Let me just add them up on a calculator. 4878 plus 12100 plus 12800 plus 6785 plus 1242800. We got the same thing. So if I move my decimal, so my decimal's here right now, 6 times, I would indeed get 1, 2, 3, 4, 5, 6, hundreds, tens, 100,000, 10,000, 100,000, millions. So the sun is still wider than all of those planets put together. Draw a picture that is close to scale. So about how many of these would fit in the sun? Whoops. So that is the sun. This is the sun. This right here. And it is has a diameter of 1,392,000 kilometers. This isn't even half. This is 100,000, almost 200,000. So this would be about 700,000. Half of that is like 3,500,000. 3.5 divided by 2. So all of the planets, so this is about 700,000. This is about 3,500,000. This is about, issue right here, 175,000. This is 179. So we are about right here. That's the width of all planets. Width of all. All that were listed. So the sun is way wider than all the others. Next. Old MacDonald's massive farm. Old MacDonald had a farm. E-I-E-I-O. Alrighty. Use the table to answer questions about different life forms on the planet. So we have humans, cows, sheep, chicken, ants, blue whales, Arctic krill, zooplankton, and bacteria. We have dealt with all of these in lesson 14. Not all of them, because these ones weren't on there, I don't think. Let's check. Sheep, chicken, ants. Oh, they are all the same. So we have dealt with all of them. On the farm, there was a cow. And on the farm, there were 2 sheep. There were also 3 chickens. What is the total mass of a cow, the sheep, and the 3 chickens, and the farmer on the farm? So total means to add. And we want their mass. So here's our mass. Let's go ahead and convert all of these to standard or expanded form. Let's zoom that in maybe. So move it 1 time. So this is 62. Move it 2 times. So from here, 2 times will give us 400. 1 time gives us 60. 0 times gives us 2. Because it becomes 2 times 1, which is 2. Negative 6 times. So 1, 2, 3, 4, 5, 6. 5 zeros in front of it. 2, 3, 4, 5, 3. 5 times. So I'm going to follow it by 4 zeros. 2, 3, 4. Negative 4 times. So I'm going to add 3 zeros in front of it. Because I go 1, 2, 3, 4. Negative 8. So I'm going to go 8 times. So I'm going to add 7 zeros. 7 and a 5, and then 1 times 10 to the negative 12th power, so I'm going to add 11 zeros, because I'm going to move it from here. There's my 1 spot, and 11 more. 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 1. So now we can add them all up easier. They all had different powers, so now we just have them in standard form. So we have the human, which is 62, plus a cow, which is 400. Plus, we have 2 sheep. Sheep are 60 each. And if we have 2 of them, we have 120. Plus, 3 chickens. 1 chicken is 2. So we have 2, 4, 6. So our total mass would be 588. Or we can put it in scientific notation. Your decimals normally. If there's no decimal, it's all the way to the right. We move it 2 times. 1, 2. So 5 and 88 hundredths times 10 to the power of 2. Make a conjunction, so make a guess about how many ants might be on the farm. If you added all of these ants to the previous question, how would it affect your answer for the total mass? How many ants do you think there are on the farm? Really doesn't matter. There's probably a ton. Who knows? There could be like 14 ant colonies. Let's say, so if each ant weighs 10, 100,000, 10,000, 100,000, million. Let's say there's 1,000,000 ants on there. So 1,000,000 ants. That's a lot of ants. Probably not 1,000,000 ants, but let's just say it. Well, that weighs about 3 kilograms. So it would increase our weight above by 3 kilograms. So we would add 3 to 588 equaling 88, 89, 90, 91. 591 kilograms, which is equal to 5 and 91 hundredths times 10 to the power of 2. What is the total mass of a human, a blue whale, and 6 ants? So a human is 62. A blue whale is 190,000. And 3 ants would be 5 zeros. Oh, not 3 times 6. You can't even tell that's a 6. Times 6. So let's see. We have 62 plus 190,000 plus, I'm going to put this in parentheses because I'm going to be multiplying this number. 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's 3 millionths times 6 ants. So we should have a decimal. We should have a Okay, well, let's figure out what is So here we go. This part of it, 1, 2, 3, 4. Is that right? One, two, three, 4, 5. That would have been right. Yes. So this itself, sorry guys, 2, 3, 4, 18. So 2, 6. That is our total weight. But we have this weird decimal over here because ants are so small. If we were to add them with the same power, we'd get something just a little bit different. So let's do that. We'll do it right on the side. Actually, we're not, because we're still going to get this weird super small decimal because ants are 3 times 10 to the negative 6. So we're just going to keep it at that. Which is greater, the number of bacteria or the number of all other animals in the table put together? So bacteria, we have it listed. The others we don't, and they don't really have the same power of 10. So we can do it. We got some moving around. So let's see. We have a couple that are raised to the 9th power. This one can be to the 9th power. This one can be to the 9th power. I'm going to need to move it 7 times. 2, 3, 4, 5, 6, 7. This one is to the 3rd power, so let's leave it for now. This one I'm going to have to move, it's to the 14th, so I need to move it 5 times. 1, 2, 3, 4. I need to put 4 zeros behind it because I moved it once. And then this one I'm going to have to move 11 times. So let's just leave that for now. Let's add up all of these that we have to the 9th power. So we have 7.5 plus 1.3 plus 1.75, sorry, plus 24 plus 50 million plus 780,000. We are at 5078034.55 times 10 to the power of 9. Left we have a blue whale, and zooplankton. So a blue whale is move it 3 times. I'm going to write this weight over here. Oops, one too many zeros. And then zooplankton would be, take 11 away, so followed by 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's see if we can move this actually. So this was our other answer. So far it's moved 9 times. So 9, 10, 11, 12, 13, 14, 15, 16, 17. Just doesn't really get us there. Let's see. I could move this one. So it's to the power of 17 by moving it 3 times. So 3 times gives us 1,000. 1,000 point all of our stuff times 10 to the power of 17. And then we have blue whale. I need another sticky note. So far we are at 1,000.507800345 times 10 to the 17th. So we are at 1,000 point all those numbers times 10 to the 17th. If we make them so they are to the 20th power, we're going to go 3 more times. 1, 2, 3, which gives us a super long decimal. Let's round it there. Times 10 to the 20th, which is still off from our 30th. So if we were to compare them, 0.05078 times 10 to the 20th, and convert this to the 20th, we get 50 billion times 10 to the 20th. So we would need about 50 billion all other creatures to equal the amount of bacteria there are. That is the end of your lesson 15 video. Your homework is page 694, question 1. We'll do question 1 and question 2. Do those on your own, rip out the page and turn it in.